Okay, it's 5.3 quadratic formula. You need to know a lot about the quadratic formula. Not just quadratic formula, it's all about quadratics. So to graph this, it would be really nice if I knew where the vertex was. If I knew the vertex was right here, because then I could sketch it really easily and go, okay, it looks like this. And then try to do the absolute value thing where you make it reflect up and all that. All right. This one wouldn't actually, if I had graphed it this way, it wouldn't reflect up. So I think it's going to be something like this, but I'm not exactly sure where the x-intercepts are. How can I find them? If you can factor it. If you can factor it, you should. All right, so I'm going to factor this puppy, and it comes out to y equals, does anybody already have it? Sir. All right, and all you have to do to be sure you're right is just FOIL it out. First is x squared. Outside and inside would add up to a total of negative x, and the lasts make negative 6. Cool, you did it. So then what are those factors good for? Well, if you want the x-intercepts, you set what? Y equals 0. For the x-intercepts, you make y equals 0. So this becomes 0. And then I find that negative 2 and positive 3 would work. So here's negative 2. Here's positive 3. Would work. Now I know it generally is right side up because there's no negative sign. So generally, before the absolute values anyway, it would go something like this. And I know the absolute value is going to change it. Do you remember how it changes it? If you absolute value its y's, any negative y's have to bounce up. So then it's going to go down like this, bounce up, and go like that. Raise your hand if you would have agreed with that so far. Okay, good. The one thing we never really figured out, though, was the vertex. And I really want to focus on finding exactly where that vertex is. Okay, that's a really important piece. These are good. Yeah, factoring gets you those, and you need to know the corollary to that. If you can factor, you should. But what if you can't factor? Quadratic formula. If you can factor, you should. If you can't factor, quadratic formula gets you your answers. All right, but this right here, the vertex, you cannot get with quadratic formula. But it helps. All right, so here's the quadratic formula. Skip down to the slide that's got the quadratic formula on it right there. All right, now the quadratic formula has a whole bunch of good stuff built into it. And if this piece right here equals 0, I want you to think about that for a second. Then it's the square root of 0, which would be what? 0. And then adding and subtracting 0 don't do anything. Add 0 to it, doesn't change. Subtract 0, doesn't change. So do you get all of this disappears when b squared minus 4ac is 0? And all I'm left with is that, which is another little formula. Does anybody remember what it gives you? It gives you x of the what? Of the vertex. If you want the vertex for the quadratic formula, you got to use negative b over 2a. Or you have to be able to do something called complete the square. I'm going to show you both of those. All right, so here's an equation. We had one already, but that one doesn't work out really nice to use negative b over 2a, so I'm going to give you a simpler one just to start with. There we go. So I know if you can factor, it should. We could do that really easy, and we can find the roots. But those are the roots are also the x-intercepts. Those are the zeros. But what's the vertex? Let me give you a hint. If you wrote it this way, do you remember that the vertex would just be right here? That's called Vertex Form of the equation. I know I'm hitting with a lot of stuff here, but it's all about quadratics, so at least it's kind of self-contained. This and this give you your vertex, but be careful. Who knows what the hook is? Yes? Not negative 3, positive 3. Very good. Why? Well, you could argue it a lot of ways, but I like to just say it this way. You don't trust the stuff on the inside. Seems like it should be negative 3. It's not. It's the opposite of that. Another way to say it is the standard formula for this has a negative built into it, and therefore this must have been minus a positive 3. However you want to think of it, that first number is the opposite of what you see in this form. All right, so there's my vertex. Now how am I going to get that from this? Well, I know the answer is 3 comma 2. Well, that was here. Let's go back to x equals negative b over 2a. You know, I told you a formula the other day that you were supposed to memorize. Who could regurgitate it for me right now? Like the penguin who's just brought back a meal for its child. Who can regurgitate the formula from 2 days ago? Penguins regurgitate? Absolutely. I'll give you a hint. It starts with f of b. Keep going. All right. If we haven't touched that in too long, you probably already forgot it. But now I just touched it again, and now you remember it for like 4 days. Cool. All right. That was to find the what? Slope. And why do we need a new slope formula? Because now things have curves. They're more complicated. Yes. So if you have a graph that looks like this, you can find the slope. And let's say I said I want it between 1 and 5. And now I got these 2 points. So you'd say, oh, between 1 and 5, what is the slope? And you'd go, okay, here's 1, here's 5. Then you got a slope of that line that goes through those 2 points. Okay, just a quick reminder of what we did the other day. So there's a new formula like that that you ought to study the night before the test, and that is this one. And that gives you the what? The x of the vertex. Very good. The vertex x. Okay, so let's everybody do that. Actually stick in negative b, divide it by 2a, and pretty quickly you get x. But the question is, what's the vertex? And that's only the x of the vertex. Yes? All right, so first of all, what did you get for negative b over 2a? Negative 6 over 2, which is negative 3. Excellent. Negative 3 is the x. And then to get the y, it's not that hard. Just plug it in, like you said. So I'm going to take this, stick it in, there, and there. And I get negative 3 squared. Go ahead, do it. Figure it out. Turn it my way. I'll tell you if you got it right. Yep, 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 yep. I can't see it. Yep, 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 yep. That's the y of it. Yep, yep. Yep, yep. Zoom in a little bit more. Yep, 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 yep. That's the y that I was looking for. Good. It's negative 4, so it's negative 3 comma negative 4. All right, so now let's start from scratch. Here's a new equation. It's not quite as pretty, but would you please figure out the vertex of this by using what I just taught you? I know you're good with computers. Is there a way to make this touch sensitive such that you could literally just use your finger and write? Okay, interesting. Oh, cool. All right. Negative b over 2a, which means negative 3 over 4. Negative 3/4. Ooh, ick. But you can still do it. The x is negative 3/4. The y will be some other fraction probably, or decimal. I know some of you are grabbing your calculators. If you didn't have a calculator, could you do it? You could. So this would be 2 times, and the negative is going to go away because I'm squaring it, 9/16 plus negative 9/4 plus 1. And then I could scale this up to make it into 16ths. And then I'd have 18/16 and negative 36/16 plus 1. and that would make negative 18/16 plus 1, and that would make negative 2/16. I'm pretty sure. Can anybody verify that? How about this? If you got it with a decimal, some of you did, take 2/16 and see if it comes out the same. 2/16 is the same as 1/8. Anybody do it with a decimal? Did you get 0.125? All right, cool. 0.125 is 1/8. So I'm going to change this to 1/8 because that's better than 2/16. Thank you for noting that, one of my students. All right, cool. That was ugly, but we found it. We know where the vertex is. And if I was sketching this thing, it'd be handy to know that it's negative, and negative puts it down in here somewhere as my vertex. That's got a slope, it's got a scale factor of 2, stretch factor of 2, I mean. So it's kind of a narrowish, steep parabola, and that's kind of how it looks. And that's all you really need to be able to find that point right here tells us so much. It tells us how low it goes, which is a local minimum. It also tells us the range, like the lowest it goes. It tells us whether or not it dips into the negatives or not. So when we absolute value it, we know if it's actually going to get affected. And this one does because it dips down in the negatives a little bit. So it tells us a ton. So the vertex is huge. But there's one more way to find the vertex that I want to show you. It's called completing the square. Two is not the ideal number to have right there. If you could pick any number in the world to have right there, there is one perfect number to have right there. Does anybody remember this from last year? I know you learned this. I know you may not recall it. What do you think the perfect number would be? 0 is not the perfect number. 9 is the perfect number. Actually, I'm wrong. It's not 9. I picked a really bad number to go from. I'm going to go with 4. I'll tell you the perfect number for 3 in a minute once you can handle it, but start with 4. This one has a nice, easy, perfect number you could have. 4. Do you remember? I tried to tell my kids a dumb little name for this, and I said it was like a little German boy's name. Does anybody remember it? Anybody in my class? Half and square. There. So, half and square. Half of 4 is 2. 2 squared is 4. There we go. Half and square it. Now, why is that perfect? Why could that be perfect? Because you see how it's perfect? They're identical. Why do I care? Because see how this works really nice? And now all of a sudden it's in vertex form. Boom, I know the vertex. The vertex is negative 2 comma 0. That's called completing the square. But that's just cheating. I just changed the number. It wasn't a 4. I just made it a 4. So we can cheat like that in math. It's legal as long as you remember what the other number was. Okay, so I'm going to go back in time because my computer remembers what the other number was. It was a... Oh, I didn't even put 1. Okay, fine. I'm going to put 1. Like I think I had a 2 there at one point. So I'm going to put a 2 here and say, close, but not exactly what I wanted. So what you do, I'm teaching you a method called complete the square. You move this 2 over, and then you say, what would I have really wanted there? Half and square. Half of 2 is 4, or half of 4 is 2. 2 squared is 4. I really wish I could have put a 4 here, so you can, as long as you counteract it by putting a negative 4 there. Is this ringing a bell? Do you remember doing this last year? Okay. So this part now works perfect, and that's my remainder. That's the thing at the end. That's the y value of your vertex. So this is y equals x plus 2, and all that comes down to be negative 2. And this is y equals x plus 2 squared minus 2. Yay, I now know my vertex. It's called completing the square. On easy ones, I think it's cool. On hard ones, like that one that came out with 1/4 and negative 1/8, you would not want to do complete the square. It'd be really icky. But let me show you one more time. I know 1 isn't the ideal number to have right there. Would you please take the 1, move it over, slide in what you wish you could put right there because it would be perfect. And we just move the 1 over for now. See if you can finish, complete the square. And then once you've got it in vertex form, I'd like you to turn it my way. That's the okay, you get the vertex form and the vertex. All I want is vertex form. Don't tell me the vertex yet, just vertex form. And you need y equals, otherwise you're awesome. Yes, sir. Yes, ma'am. Yes, sir. Yes, ma'am. Good. 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 Okay, most kids are getting it. Let's show you what it should have done. You should have said half and square. Half and square. Half of 8 is 4. 4 squared is 16. Plus 16 minus 16. This part's perfect. X plus 4. X plus 4. Which I could have just shortened up and said x plus 4 squared right off the bat. And that's the shaping up to be vertex form. I know you learned it. If you were in honors higher algebra last year, you learned it. If you were in FST, you might not have. And if you were in regular higher algebra, you might not have. But this is called complete the square. And what's cool about it is it makes you know that that's a perfect square trinomial. 1, 2, 3 terms. Perfect squares are good things to know about later on in math. And secondly, it gets you the vertex. And then I know the vertex is now -4, -15. And that's important. Important to know because it tells you the range of your function. It tells you the minimum of your function or the maximum of your function. The vertex is like a key spot. Think about it. On a curve here, what's the most important spot? I'd say if there's any most important spot, it's that one. Second place is probably where it crosses the x-axis, these guys. Okay. So, if you're given this one, first thing you do is try to factor it. If you can factor it, you should. And if you can't factor it, what would it solve it? Say it louder. Quadratic formula. Good. And then if you wanted the vertex, you could complete the square, but I have a feeling complete the square on this one would be icky because of that. In fact, I know how to do it, and I taught it last year, but I feel like I just would never do that. What would I do instead to find the vertex? That formula. And the quadratic formula part, the only part of it that's important is the x equals -b over 2a part. Would you please use -b over 2a to find this one? It's going to be icky, but you got to be able to handle it. You're an honest pre-calc. Not all super nice numbers. Did you get -5 over 12? But is that the whole answer? No, it's just the x. Now I'm going to save you the time. If you can't handle this, though, that would be scary for your next test. You have to be able to handle multiplying out icky fractions and putting them all together and stuff. All right, so it comes out to -5/12 comma something, which I'm not going to take the time to do because we need to teach you a lot more stuff. And that one, we would never make it that intense. Okay, so I've taught you how to find these guys by doing, if you can factor it, you should, or if you can't factor, you can use the quadratic formula for them. Sometimes if you can't factor, it's just because these are weird decimals here. Sometimes you can't factor it and the thing's up here. Would this even have roots? No. That leads us to another part of the quadratic formula. Notice that red part? That red part can either be greater than 0. If it's bigger than 0, that's kind of what you want. That's a normal answer. And how many answers will there be? 2. What if that's less than 0? It's impossible because you got a square root of a negative. And I'm going to call it imaginary instead of impossible. You'll have imaginary solutions. They'll have i's in them. Square root of negatives come out to i's. All right, and the last thing is, it could be equal to 0. And remember how if this whole equals 0, then all of this goes away, and then you're left with this. And so if it equals 0, you only have one solution, and it is the vertex. Your solution will be the vertex if that equals 0. All right, so this goes along with this slide in here. It's this purpley slide. So I just told you this a second ago. B squared minus 4ac is less than 0. Imaginary. And therefore, no real solutions. If b squared minus 4ac is equal to 0, the vertex. And if there is a vertex like this, by the way, it's also touching just like that. That's why there's only one solution. Okay, and the last one is, it's bigger than 0, then it's normal, and it could be 8 billion different combos of it's touching twice, but we just don't know exactly where. All we know is there's two solutions. All right. Yes, sir. We're not at that point yet. At one point we will be. So like instead of just saying it's 2 plus and minus the square root of negative 12 all over 6 and saying, oh, no solutions, we'll actually boil this down more and get an answer that has I in it. I'll show you real quick. This would be root 4 and root 3 and root square root of negative 1. Or the root is the root of negative 1. And this is I, and this is 2. And so then this would become 2 plus and minus 2I root 3 all over 6. And then the 6 can be factored, and if you can factor it, you should. 2 times 3. Why was that smart? Because now, oh, the top can be factored, and a 2 comes out of that. 2 comes out of the top. 1 plus and minus I root 3 all over 2. 2 up the top and 2 on the bottom cancel, and there's your answers. 1 plus and minus I root 3. It's not that hard. Honestly, you can do that. All right, so let's look at typical homework for today then. These first couple are really good overall practice of quadratics. This one, also good practice. And if you're going to make this graph, do you get why I went through all that time of helping you figure out where the vertex was? Because if I told you the vertex is right here, wouldn't you be able to sketch it really quick? I mean, you got a negative 3, so it's negative, so it's got to be something like that. And you'd know its domain and range because the vertex is the only really important point for figuring out domain and range. Because once I know that, I know how highest it goes is whatever that point is. Okay, so that's why I spent so much time talking about vertex. If it touches, great. Those are the x-intercepts. And what if it touches, but they're weird decimals? How are you going to get it then? Because it won't be factoring if it can't factor quadratic formula. So I'm going to say it one more time. If you can factor, you should. If you can't factor, what? Quadratic formula. Okay, good. All right. And all of those were assigned. I am skipping this one because the question doesn't come to the middle, and I don't think it's worth it. It's a little complicated. This one, it's nice. I think you should do it. Not saying it's super easy, but it's very similar to what you do on your tennis ball lab. So I think it'd be good for you to do. This one we are skipping because it is a challenger question. Obviously, I encourage you to take the challenge if you've got the time, but it's not assigned tonight. Next is these top 3 are all really good ones, and they're about b squared minus 4ac. Remember, if they're asking how many solutions it has, that's code for saying you better use b squared minus 4ac. Because that tells you how many solutions you have. All right, and I'm going to have you skip number 10. Then, these you may also skip. This is a quiz that you won't do until Friday, and I might actually tweak it a little bit, but I do want to kind of catch you up with where we're at. This is not a major test tomorrow. That's not what I'm saying. I'm going to give you a little homework quiz tomorrow. See if you still remember how to find slope on a curve. All right. And that's it. That's all we have for today.